Not the vicious cycles. Cycles in permutations. We have considered several enumeration problems in the previous 3 chapters. One of them, that of permutations, stands out by its omnipresence in mathematics. The reason for that is that permutations can be viewed not only as linear orders of different objects, most often elements of n braces, but also as functions from n braces to n braces. In particular, a permutation p equals to p1, p2, p3 until pn can be conceived as a unique function p which maps from n braces to n braces, for which p of I is equals to pi. Example 6.1. The permutation 312 can be viewed as the bijective function f which maps from 3 braces to 3 braces defined by f of 1 is equals to 3, f of 2 is equals to 1, and f of 3 is equals to 2. The advantage of this approach is that now one can define the product of two permutations on n braces by simply taking their composition as a composition of functions. Example 6.2. Let f equals to 312 and let g equals to 213. Then f and compose g of 1 is equals to g of f of 1, which is equals to g of 3, which is equals to 3. And f compose g of 2 is equals to g of f of 2, which is equals to g of 1, which is equals to 2. And the f compose g of 3 is equals to g of f of 3, which is equals to g of 2, which is equals to 1. Therefore, f compose g is equals to 3, 2, 1. Example 6.3. Let f and g be defined as in the preceding example. Then g compose f of 1 is equals to f of g of 1, which is equals to f of 2, which is equals to 1. And g compose f of 2, which is equals to f of g of 2, which is equals to f of 1, which is equals to 3. And g compose f of 3 is equals to f of g of 3, which is equals to f of 3, which is equals to 2. Therefore, g compose f is equals to 1, 3, 2. As these two examples show, multiplications of permutations is not a commutative operation. That is, it is not true in general that f compose g is equals to g compose f. The reader may have seen examples of such operations before, such as metric multiplication. Exercise 11 explains why multiplication of permutations is a special case of that. Operations involving multiplications of permutations are the subject of the theory of permutation groups. Our book walks through combinatorics and will not contain a digression to that very interesting field. Some of the exercises at the end of this chapter do relate to the multiplication of permutations, however.